Let's take a trip back to January, the start of semester 2 in Mr. Condi's marine biology class. Studying lower invertebrates may have been interesting for you or others, perhaps when talking about the easiest categories phylum Porifera and Cnidaria. Though we may think that the organisms are the exact same thing from both phylums, there is a major difference in the identifying and characterizing them. I'm not going to spend a lot of time on these differences, because today's topic is all about coral bleaching and the diseases that are behind this cause. When you think of phylum Porifera, sponges should come to mind. They are sessile creatures that lack tissues, but make up for it in collar cells. Collar cells contribute to the flow of water moving through their tubes and collecting bits of plankton with tiny hairs along the inner walls. Phylum Cnidaria is known for, cnidae, the spear-activated organelles that inflict sharp pain if met with contact. You may think of jellyfish, sea anemones, gorgonians, and of course, corals. I mean, I wouldn't be bringing this up if corals did not even affiliate with this topic. Nearly all anthozoa organisms are attached to the seabed, and their larvae are dispersed widely thanks to the plankton that goes in and out of its tubular system. If you observe this image of the skeleton, you can see the network of organ systems, but the lack of organs present. Processes such as nitrogen cycling, photosynthetic transference, and nutrient cycling are essential in their roles as to maintain and fertilize coral larvae. However, coral faces an extremely dangerous threat: coral bleaching. Coral bleaching expels symbiotic zooxanthellae, which contain photosynthetic pigments that give off its bright, colorful appearance. Losing them gives this pale bleached reflection as the calcareous skeleton now shows their translucent tissues. The stony coral tissue presently surrounds the colonized areas of St. John and Puerto Rico, where scientists have determined if the same disease is like that of the ones along Florida's coral reef. While there are a range of possible feats that the bleaching may cause or appear to look like, the point is they can be close to even, which means that what it came down to is the rising temperatures and infectious diseases that can enter the unprotected corals. Shockingly, over 20 types of diseases have been identified as most affiliated with the great mortality of these producers. 3 will be touched upon by the easiest and most recognizable: black band, white band, and CYBD. Black band disease persists with the combination of bacteria and cyanobacteria. Its name comes from a dark band of microbes spreading across the long pieces of coral tissues, revealing the white skeleton after it finishes feeding on the sun-emitting pigments. Because of the rate at which it can expand, coral does not have enough time to grow new skin or tissues. I mean, realistically compare the skin of your body with a particular reaction like eczema or hives. Skin, in this case, is the first line of defense, and without it, the body is susceptible to infections and any bacteria that may find its way into the organism's body. For coral, black band prevents oxygen intake, with an increase in hydrogen sulfide tearing through the layers of coral in an instant. With bacteria on the exposed coral, it becomes free-floating, traveling the ocean to other coral reef communities by particle. Since its first discovery on Atlantic reefs, it has been identified in all global oceans. White band works in a similar way, but targets the skeletal tissues of the coral. Specific species of coral like staghorn and elkhorn corals will commonly face this disease. Of thousands of coral species, these particular 2 are essential in building up the Caribbean reef beds, and today more than 90% has been lost. There is no treatment to slow the spread of the white band, and researchers are desperately trying to get them off of the endangered species list. With enough evidence, scientists are nearly certain that bacterial infection is the culprit. Based on how the deterioration in the coral is caused by an attack of microbes, what remains unclear is where they came from and how they duplicated. If it was in the coral already, then the extreme environmental conditions make it harder to regenerate and heal from the infectious host. CYBD gives off a moldy yellow patch, which will kill coral in the center of the splotch. Affecting only coral in the genus Montastraceae, the Arabian Gulf coral reef community has eliminated nearly all of its coral. Its cause is unknown, but researchers think that it has been developed from the environmental changes in the surrounding areas. The presence of cyanobacteria or other variations of bacteria can be the major cause of coral bleaching, but not always. Temperature changes like particularly warmer waters, are captured by thermal readings rising at a rapid rate. At this moment, there may be a connection. It's the overexposure of sunlight, which happens when temperatures are so high solar irradiance or radiation beams onto areas of shallow water corals. It is extremely risky for corals in those zones because there are extremely low tides, and with exposure to the air, they can easily lose their zooxanthellae. However, the same cannot be said that coral bleaching is not all due to warm water. There have been studies since January 2010 where cold water temperatures in Florida Keys caused a coral bleaching event, leaving some dead. It was clinically recorded that water temperature dropped negative 6.7 degrees Celsius, much lower than the typical temperature at the time of the year. Researchers have not fully evaluated if cold stress events will make corals more susceptible to disease, but with further research, the hot summer temperatures are what really caused the loss of photosynthetic tissues. So you may ask, what is my take on this issue of coral bleaching and disease? Well, coral bleaching can spread very quickly with the ongoing effect of human activity, global warming, and the spread of bacteria or cyanobacteria in our aquatic ecosystems. If actions are not taken quickly to save the corals, all life on Earth can be put at risk. With scientists doing their part to research and coordinate methods to track and preserve the reefs in our major oceans, it is up to us to make an adaptable impact with our emissions and environmental choices.